right, welcome back to section 10.1. The next thing we're going to look at is roots when you have a power underneath the root. Okay, so what's going to happen? Let's look at some of these examples here. The first one I have is the square root of 15 squared. So what's going to happen here is that the squaring is going to happen first. Inside of the square roots, it's almost like a parenthesis or something where you're going to do what's inside the root first, and then you take that square root. So you're going to do 15 squared first, and then take the root of that. So you would actually do the square root of 225, which would bring you back to 15. And so that root and that squaring, they kind of undo each other. But just keep in mind that when you do this, you'll get a positive value, and then when you take the square root, you're going to get a positive value. So in B, where we have the square root of negative 12 squared, what's going to happen is you're going to square the negative 12 first, which would give you a positive 144, and then you'll take the square root of that to get a positive 12. And so you'll notice, well, these kind of undo each other, except that you don't get the negative 12 back, you get the positive 12 back. So really what's happening is these undo each other, but you end up with the absolute value of whatever is underneath that square root inside of the squaring. Okay? So when I have the square root of this negative y squared, you think, oh, they're going to cancel out, right? You're going to have the square root of y squared, which is going to give you y. But I don't know if y is positive or if y is negative. So if y is positive, then yes, you'd end up with y. But if y is negative, the opposite of the negative number would give you a positive. You'd square that, which would give you a positive. And you get a positive here, which would actually be the opposite of what you started out with. So what we're going to do is we're going to use absolute value bars to indicate that the y value is going to be the positive version of whatever it started out with. Okay? What if we have higher roots, we have other ones, right? So let's take a look at these. So the first one I have is the fourth root of negative 5 to the fourth. So when I do negative 5 to the fourth, I'm going to get a positive value, right? And when I take the fourth root, I'm going to get another positive value. So what's going to end up here is that these, yes, they cancel, but you're not going to get negative 5. You're going to get positive 5 as a result. All right. What if we have the negative on the outside? So I've got the negative sixth root of negative 3 to the sixth. Well, 6 is still an even number. So when I do a negative raised to an even power, you're going to get a positive result. And then when I get that positive number, I take the sixth root, I'm going to get a positive value. And then at the end, I'm going to have that negative from the outside, which is going to give me a negative answer. So the 6 and the 6th root will cancel out, but we're not going to get negative 3. We're actually going to get positive 3. Then we have this negative from the outside, which will make it negative again. All right, last one. What if I have the fourth root of 2 to the 8th? Wait a second, those aren't the same. They don't just cancel out, do they? So what's really happening here is that 2 to the 8th, that's 8 2's multiplied together. 1, 2, 3, 4, 5, 6, 7, 8. And we're taking the fourth root, which means I'm looking for groups of 4. So I can have one group of 4 and another group of 4 come out. So I'm going to have two groups of 4. So really that's going to be 2 squared, or 4, for my answer. And if you want to get this a little bit faster, you can actually do the 8 from up here divided by the 4 from the root to get that 2 a little bit quicker if you'd like to. Okay, now it's your all's turn to try another one and show me how much you've learned.